Thank you. Good morning. My name is Dirk Hohndel. I'm VMware's Chief Open Source Officer. And I'm very grateful that VMware A sponsors this event and B allowed me to travel here. And that's the only thing that I'm going to say in this talk about VMware, because this is decidedly not a VMware project. This is a hobby project that I've been working on for quite a while. So what I'm going to talk about today is how you can develop for multiple platforms without losing your mind, where not losing your mind is a relative term. But I want to make sure people understand, I never present with slides. I always have slideless presentations, and I love it, and there are many reasons for that. I do make one exception, and that's whenever I talk about Subsurface, because fundamentally, this is what it's all about. This is all about diving. And a quick show of hands, how many here are scuba divers? That's what I figured, because typically to these talks, we do have a lot of scuba divers showing up. So I always, as Keith says, I'm like the grandparent who invites you for dinner and then forces you to look at their vacation pictures. All of these pictures are from last week in Fiji, and so enjoy. So what is this all about? A few years ago, 2011, this guy here, who some of you may know, got bored because the kernel.org server got hacked, and Linux couldn't work on Linux for a few weeks, and instead he started working on a divelog program called Subsurface. And about a year later, I took over as a maintainer and have been maintaining it since. And I've talked about this quite a few times here at LCA. First, what is this? How did we get started? So that's LCE 2013. Then our migration from GTK to Qt in 2014. And then how to maintain an active community in a niche project like that. That's 2015, the last time I was here. And then the last 3 years, we didn't quite make it because of a job change on my part. And since, a lot has actually changed. And the code of conduct says that I shouldn't discriminate about certain groups in any way, shape, or form. So I'll say, the generational change without trying to be derogatory about the young folks. But it's very noticeable when you talk to divers that more and more don't want to travel with a laptop. And that a lot of the people who reach out to us do so because they are looking for a mobile application. And a tablet to them is a big computer, but preferably they want to do everything on the phone. And it's a very interesting shift in how people approach software and how your application gets used. And our first attempt, you see Mark here in the front with his, 19-inch screen and 6-pound laptop, and people don't want to travel with that. And we see this in the influx in new users, that most of them actually now come through the mobile app, and then only later say, oh yeah, but editing is easier on the laptop or on the desktop. And the first temptation, of course, is to simply take your desktop application and try to somehow make it work on the mobile device. That's a really bad plan, because fundamentally the UI thought behind the desktop application is that you have a keyboard and a mouse being specifically a high precision pointing device. So you can make just a couple of pixel adjustments on the screen, and that feels very natural, whether it's a touchpad or whether it's a real mouse, doesn't matter. On a mobile device, that is the worst possible design decision that you can make. Everything is touch-based. Touch is very coarse. And the thing that drives me crazy whenever I work with mobile devices to do anything useful is when you touch, the thing that you're touching, you're covering with your finger. So you can't see what you're touching. So all the UI elements need to be designed around that fundamental idea that it's different from what you're doing at the desktop. So we very quickly decided that trying to take what we have for the desktop and somehow just make it bigger, clunkier, but then use the same UI on mobile wouldn't work. And trust me, we tried. And so in order to go to Android and iOS, you immediately, which are the two mobile platforms that really matter. I mean, Windows gave up, I believe, and there isn't really anything else. But of course, they have extremely different development environments. You have, am I allowed to call it Java, that thing, Darwin, whatever, on the one hand, and you have Objective-C and lately Swift on the other hand, which are very, very different in the way you interact with them, completely different IDEs, completely different access to libraries, and really very different development philosophies. For us, we had so much code written in native code in the desktop application for the infrastructure that we use, whether it's downloading from the Dive computers, whether it's interacting with the cloud service on the back end, whether it's a lot of our internal logic, how we deal with the Dive list, with all the information that we want to present to the user, that we really didn't want to have to redevelop all of this twice for 2 different platforms in 2 different languages. And of course, as the maintainer, I will say I speak neither Java nor Objective-C. So there was a strong desire to be able to reuse as much of what we had as possible. And we have quite a few dependencies. So we want to be able to talk to Dive computers. Now, modern Dive computers thankfully increasingly support BLE, which means you have a chance on an iOS device to talk to it, because BLE is the only thing iOS devices talk to. Wi-Fi, yeah. You see a ton of Bluetooth Dive computers, which at least on Android, most Android devices you can talk to them. And the majority of older Dive computers, and still many of the newer ones, are serial or USB devices, which on Android kind of, sort of, sometimes works, but there are issues, and on iOS generally doesn't. One of our challenges, by the way, and why serial doesn't work always on Android phones, is that we're using native libraries. And on Android, if we had a Java application, there are APIs that make it fairly easy to talk to your serial device, to USB device, but then we can't do anything with that information in Subsurface. And libUSB, which is native code, then on many modern Android devices, including, thank you, all Google devices, gets access violations. So we still need to tune this a little bit. And oh, by the way, much of what we're talking about here is work in progress. The mobile applications have been out for 3 years, but I will tell you quite frankly, they are not all that great today. So when you have a Qt-based application and you want to go mobile, the logical way to go is QML. QML was brand new and a fantastic idea about 8 years ago. Has matured quite a bit, but fundamentally it looks like this. It's very, very simple. It describes a shape on the screen and what happens when you interact with it. It really, first time you look at this, you look at the little tutorials, and it doesn't look hard. And you're like, oh, this is pretty cool. Keith is laughing. You think, I can do this, right? Well, and then you try to actually do things. And that's when it gets really hard. Yeah, Linus is showing, this Flabellina that you see there is roughly about yay big. It's about 8 millimeters from nose to tail. Because QML has absolutely nothing besides rectangles that you can outline and fill and stuff, gradients, cool stuff, text fields, even for input, great. And it can react to mouse, so it has these mouse areas you saw in the previous examples. And that is it. There are no widgets, there are no UI libraries, there is nothing. It is about as bare bones as it gets. And you get to wrap your mind around the difference between declarative and procedural programming. Sounds really simple, sounds like something that you just describe what the desired outcome is, right? That's what declarative programming is all about. It's like HTML5 pages, you draw the picture. But then when you look at a typical application, at least the way my brain works, is something where I say, well, if that happens, then I do this over there, and then I execute here, and then I want to do these things, and then I wait for that to happen. So it's all a flow of process. And doing that in something that is designed to be all declarative, just describe outcomes, and then everything happens through magic signals and callbacks, and it was an insane learning curve for us. And it could be because I'm dumb, and I always assume this as the default answer. But the majority of the developers in the Subsurface community were all struggling with that very same problem. It was really, really hard. Now, we did, thankfully, very early on, run into the Kirigami project, which is part of the KDE Plasma community. And so what Kirigami does is it tries to create this next layer above QML. So have a decent set of widgets, have a vision of how the flow of an application should be done. So they have these page stacks that you can swipe between pages. They have a lot of much more complex UI elements. They have ideas around theming, around a user interaction model. So a lot more structure, a lot more widgets, and most importantly, they provide help. And I've said this when I was here 5 years ago, and I talked about the switch from GTK to Qt. The thing that is amazing about the Qt community and the Plasma community is the amazing amount of help that you get. So one of the Plasma developers actually took the time, he happens to be a diver, he took the time and gave us over maybe a month a rough basic structure for here's how you could do this. Here's how you could create the list with the dives. Here's how you can flip between the lives. So the community actually reached out to us and helped us develop the very first pre-alpha version of this UI on top of our infrastructure. So that was incredible. And to this day, when we have these holy moly, why doesn't this work moments, we reach out to them, someone will show up and say, oh yeah, I tried to compile this and yeah, just do this magic thing over there. And oh, by the way, the number of times that the answer to your question is, oh, there is this magic thing you just have to know. Yeah. And I think this last point here is important. We were the first outside project to use Kirigami. So everything before us were either the Kirigami's own sample applications or projects inside of Plasma. So people who were in the community who had helped create the toolkit were now using the toolkit. And having someone who doesn't spend all their time thinking about the way Plasma is supposed to work suddenly try and use this and use the documentation. Yeah, documentation, by the way, is good. It would be nice if there was more. The name is awesome. If you try Googling for Kirigami, you learn a lot about paper folding, which is why I have the link to where you can actually find Kirigami. Because on Google, it's like 6 pages in when you get the first link to the thing that you're actually trying to look for. So I talked about declarative programming, and I talked about some of the things that I find challenging with this. So this is a button, right? You saw that right away. It's a rectangle, it has a name, it has some control when it's visible, shape, form, height, color, radius of the corners, the anchors. This is HTML, so how it positions itself in everything around. You set an icon, the icon is positioned within the... It's very verbose. And it's actually pretty hard to encapsulate this into your own little meta structures and reuse your structures. We've tried some of that and ran into a lot of limitations. And the other thing that you can see here, and you won't even notice, is you can interact directly with your C++ code. Who finds the point where I interface with my C++ code? Okay, yeah, that was about the speed of response that I expected. The very last line, manager.paste dive data and you pass it in it. So that's when we call into our C++ application, hand it an ID and say, oh, there's the thing we were trying to do. So this interaction with the objects of your application is the major strength of QML, and it's the biggest pain in working with QML. As I said in the beginning, for us, goal number one was to be able to reuse all that code that we already had. Linus, as we all know, is a very strong proponent of writing good C++ code, right? You met him. So, of course, Subsurface's initial title was a divelog written in C. When we moved to Qt, of course, we added a lot of C++. And the only thing QML will interact with is C++ code, which creates some layers of indirection that are interesting for us. But the way it interacts with C++ code is insanely unintuitive to me. So there are three fundamentally different ways in which you can interact with C++ code. You can make classes available which are instantiated at moments where you don't want them to be instantiated and don't always use the constructor that you wanted to use, and sometimes are singletons and sometimes aren't, and create the most fascinating and hard to track down bugs you have ever seen. You can also export a single object to QML, which then also does very unexpected things, especially when the QML page closes. And whether or not that object gets destroyed depends, I think, mainly on the phase of the moon. And then you have this really useful way of just calling functions. You can make functions callable from your QML code, and that always works. Which, as a result, of course, means that that's what you do. Which, as a result, means that you write horrible code. And so every time the QML folks, as I said earlier, they typically show up every once in a while and help us. And usually the response is, you're doing it wrong. That's not how you're supposed to do it. But that's the easy way to do it. So it's an interesting challenge, and I'm not sure if this is a documentation problem, if this is my brain just doesn't work well enough problem, I don't know. The other problem is, well, this is our app. This is on, well, obviously on Android. Couple of screenshots. Who thinks that's beautiful? Yeah, that's exactly the problem. It's really not. And it's this, again, I don't want to diss on Kirigami or on QML. This could just be that we're not good at this. And I'm sure you could do much better. But it's really hard to make something that looks great, that looks tight, that looks easy to use, that is intuitive, that seems, I mean, to me, this wastes so much screen real estate. And yeah. The other part that is really important to notice when you look at this, so I told you this is Android. Because normally when you look at an app, you can immediately tell this is an Android app or it's an iOS app. Because there is this design philosophy, how these apps are supposed to look. And this looks like neither. Okay, so that Kirigami is its own thing, and that can be a good thing and that can be a bad thing. So the one thing that is nice is you have one manual for your mobile app because it looks the same on both platforms. It's nice that there is consistency for all of us who use both iOS and Android, which are, yeah, never mind. The downside is that all the Android users are telling you, you're doing it wrong. Look, here is Google's documentation. And all the, never mind, you know what the iOS users are telling you. So we struggled with this. We struggled with this a lot. In the user feedback, so our Play Store and iTunes reviews reflect that everyone thinks that we suck. I can't argue with them. But on the flip side, you do it once, and you can run the same mobile app on your laptop as well. Wonderful for debugging. So not in a simulator. No. You can run this natively on a Mac. You can run this natively on your Linux box. And you get the same UI. You can test everything, all the flows, everything. has a ton of advantages. And remember, the idea of this talk was that you have a desktop app, and you want, and a complex desktop app, and you want a way to relatively easily get to a mobile app. So I think the key learning here is that careful what you ask for, because you can absolutely get relatively easily, and I think many of our detours and many of our challenges in the early days were also because Kirigami was very, very early. We started at Kirigami, I can't remember, 0.8 or something, so before even they thought it was ready. It is relatively easy to get started, but it creates something that may not be exactly what you are hoping for. And my biggest complaint, and people who have heard me talk about this will be maybe surprised, there is no user interface, no GUI to create your user interface. So you're back to the 1990s of having boxes and layouts and doing this all in text and then running it to see how it flows. And then you look at this and you go, why the heck is there this empty space above div 534? And why, if I try to remove this, does it then overlap with the top? And what is going on? So there are definitely shortcomings there. The other thing that is really interesting is developer skills. QML, who here is an experienced QML developer? Talk to me, please talk to me. Yes, I found one. Linus, can you tackle him so that he can't leave after the talk? This is just like a floating flatworm in the middle of the water that you can actually take a picture of in focus. It's about the same thing with finding a QML developer. And the flatworm, the guy in front is in focus. And that guy is about, yeah, not big. Anyway, if I look at we can do this in the room. Who thinks they can write an Android app? Yeah, see, order of magnitude. iOS app? Are we an open source conference? Okay, 2 people. But fundamentally, when I look at the typical people that want to talk to us are, surprise, surprise, divers, scuba divers, free divers. And it's not an order of magnitude. It's 4 orders of magnitude. I have had so many people talk to me who say, oh, I'm a Java developer, I'll help you. That's great. It's not written in Java. There's like 20 lines of GNI in there when we try to get a list of paired devices from the Bluetooth stack. It's incredibly hard to find developers. But then on the flip side, if I look at the oodles, the megabytes, the million lines of native code that we have, and making that work with Java or with Objective-C and dealing with all those nightmares. I mean, I started this. I tried to create something that would call into our code from Java. I'm not a Java developer, but I tried, and it was a nightmare. So it's this trade-off. What do you do? What do you want? Which battle do you want to fight? I talked a little bit about connecting to C++ earlier. Let's start with documentation. The documentation shows you 6 simple examples that all do exactly what the example tells you that it's going to do, which is absolutely not what you actually want to do. And then trying to understand from these examples how it actually works. Nowhere does it mention that your type cannot start with a capital letter. Nowhere does it mention that while in the QML code, these suffixes of the signal names have no underscore. On the C++ side, they have to have an underscore, or it's the other way around, I can't remember. There are all these magic rules that you somehow need to know, and that once or twice change between releases. Oops. I mentioned this briefly earlier, the object creation heartaches. I'm not an object-oriented programmer, as you can tell by my age. But this fundamental problem that you have you cannot easily control when the objects that are owned by QML will be created. So if this object relies on somebody else being created first and then tries to call into it and it crashes, and you try to figure out why this thing is crashing, or it reads a default value because the default constructor has been run, but the object hasn't been initialized, and the actual value, for example, if you want metric units or imperial units. This is one of those things that we have in one of our C++ objects, very simple. Yet the UI, because of the timing when it was initialized, always saw the default value, which for all you metric people is wonderful. For the people in the 2 third world countries that actually use the imperial system, it was a little annoying. And I live in one of those countries now, called the United States of America. And I complain a lot. I'm German by birth. It's the national pastime. But I want to point out, once it works, so once someone sends this magic pull request that somehow changes something about this object that I still don't understand, and suddenly it all works and it all sees it, it is beautifully easy. So once you have it all hooked up correctly, then you have massive advantages here. Because the QML code can now actually just talk to all of your data structures. It sees your models. You can, if you have a bug in your sort order or whatever that you fixed on the desktop, it magically gets fixed on all of your platforms. So Windows, Mac, Linux, Android, iOS. I don't have to fix the bug 5 times. And if it works, and once it all is tied together, it actually makes for a very nice way to be able to pick and choose which of your features you make available in your mobile UI versus your desktop UI. Our desktop UI today is significantly more complex, has a lot more features. And I think the #1 request that we get is, oh, can you add this one configuration option? So I talked about imperial versus metric units. And of course, on the desktop, we allow you to say, well, no, I want PSI for pressure, but centigrade for temperature. And you immediately get the same feature request for the mobile version, which of course, with limited screen estate means your settings get more and more and more complicated. But it's very easy to make these trade-offs, because you develop a new UI from scratch that has access to all of the infrastructure that you have built to develop your desktop UI. So anything that you have done on the desktop, whether it's filtering, the whole infrastructure in your object hierarchy that allows you to filter in various complicated ways with exclusions and overlapping constraints and whatnot, that understands how your data works. All you need to do is a little UI that calls into these 5 functions, and you have filtering on the mobile application. It is really wonderful how all the work that you've done now becomes reusable. So with all my bitching and moaning about the complications in getting this done, and that maybe the outcome is not exactly what I wanted, I also want to make sure you understand it makes it really, really easy to make progress. There's one more problem for a mobile application, which is packaging. So I may have talked about packaging on Linux before. Packaging on Linux is really, really frustrating. Packaging for Android and iOS is so much more frustrating that I have considered stopping this several times. The tools are all designed around, you're in Android Studio, you have a Java application, click here, you're done. That's not what I'm doing. I, of course, built with native tools. I built with GCC or Clang from a script. We use CMake. We use all kinds of things that no one expects you to do. It's even worse for iOS. You basically cannot package for iOS unless you open Xcode. You can find lots of websites that show you how you can script this with the Xcode run tool, and the very next version of Xcode will break it reliably. So packaging is an unbelievable pain. It is very, very poorly documented. It's poorly documented from Google and Apple because they all document it around their preferred infrastructure. It's very poorly documented on the Qt side. You need these random third-party open source projects that randomly stop being supported and that tie together the CMake configuration with some Java tools that create something else, and over here you can sign. It's very, very hard. There's a ton of magic, and you have randomly your packages not working and trying to figure out why they no longer work. So Apple changed the rules for how things have to be signed. And there's a one-file artifact from our packaging mechanism that ended up in the package, and having a single unsigned file in the package made the package invalid. Finding that took me, I think, 2 weeks. And it's ridiculous because it's all an automated process. Everyone who uses this process should have the same result. Oh, did I mention that, to the best of my knowledge, Subsurface Mobile is the only Kirigami app that is in both the iTunes Store and the Google Play Store, which explains exactly what my problem is. We are an extreme niche user. We're doing things that most everyone else apparently isn't doing. So please, all start some QML-based mobile applications that you put into both stores. Because yes, I make it sound so, thank you, Keith. I make it sound so tempting. It's fantastic. I highly recommend it. But yeah, this really is the single biggest downside compared to using native tooling, is the constant challenge with the packaging. And every time a new version comes out from iOS, every time a new version comes out from Google, they break something for me. And then, of course, that bottom, yeah, so if you read through the rules of the iTunes Store, Richard Stallman has said very clearly that he believes that you cannot actually put GPL code into the iTunes Store. We have made the decision that since we own the copyright on Subsurface, we don't really care. And for all the libraries that we use, it's all open source. You can all recreate it. We give you all the scripts. There are container images that have all the tools in them, and you can just build it yourself. So we're pretty sure that we actually are sort of mostly kind of compliant with the licenses. I am not a lawyer. But it is a challenge. So be aware of that. If you have people with a very strong open source compliance bent in your team, you may get a little noise on that. We have not been challenged. So we have declared the license both to Apple and to Google, and both, we've never heard from them. You have the review processes that take forever. So they know that we're doing this, but yeah, beautiful packaging is a beautiful thing. That's the ghost pipefish there. So what's my summary? We knew what we wanted. We absolutely had this vision that we wanted to reuse as much code as possible. We wanted a low overhead way to create, those are little gobies there. Oh, the green stuff, that's just a green coral that looks like a, No, it doesn't look like an octopus. It's just so these buttons here are maybe 2 millimeters in diameter. This is again macro. Most everything that I showed was macro. We still don't quite know how to get what we wanted. So we got something that's fairly close. We have mobile apps that reuse the vast majority of our code. We have automated testing on Travis. We have all these wonderful things, but the apps are not as beautiful as I would like them to be. The apps aren't as intuitive as I would like them to be. The process is still too painful for what we really want to get to. There is one problem, and this cost of change versus sunk cost fallacy. Those of you who were here when I talked about the migration from GTK to Qt know that we have taken those dives and said, okay, we give up on this, we try something else. I have been tempted a couple of times in the last 3 years to say, okay, I'm done. Let's start a Java app because this is not worth it. This is an incredibly hard trade-off. Because as I said earlier, whenever you actually have these pieces working together, the ease of being able to reuse everything, all the infrastructure that you've created for the desktop is so tempting, is so positive, makes it so easy to make progress. We keep going back to, no, let's just try one more time. But I'm still not entirely happy with the outcome. Conclusion. What I'm talking about here is cross-platform development squared. Because it's cross-platform in that it's Windows, Linux, Mac, and iOS and Android. But it's also cross-platform in that it's desktop and mobile. So it's in 2 dimensions cross-platform. And that is incredibly hard. And I did some searching prior to submitting the abstract to see how many other projects do that. And I didn't find a single one. I have not found another project that supports these 5 very different OSs across 2 very different usage scenarios out of a single code tree with a relatively thin layer of UI on top for mobile versus desktop. So in a way, this is something that is very, very unusual. But I think it's something we'll see more of as mobile apps are becoming so important. In the abstract, I say something silly like maintain your sanity, and several of you were kind enough to point out that my sanity is questionable to begin with. So let's take this with a grain of salt. There is a lot of frustration, but there's also a lot of really exciting success. When we are on a dive boat and we can download on the dive boat from the Bluetooth dive computer and it just works, you push it up into the cloud, you go to your laptop, you download it on your laptop. It all is there. It all magically works together. I look forward to that day. No, I mean, usually it works, and then you try and install your latest development version, and it crashes when downloading from your dive computer. Hey, Linus, have you debugged that yet? Damn. Okay. So understand the trade-offs. It's a wonderful thing to do. It's very rewarding. It makes it possible to do things that apparently no one else has tried. To the one gentleman who knows QML, don't walk away. To everyone else, I left 15 minutes or 10 minutes, I think, for questions. Okay.
So I managed not to be in the role of lead interviewing, so I don't know the answer. But
so Mark asks if Flutter may be the answer that we were looking for. So I looked at Flutter when we made the decision to go with QML, and back then it looked like this isn't really what I want. It didn't have as much integration with the way our data structures worked. So the really nice thing about QML is that it is the extension of Qt into the mobile world. So it really is designed to do the thing I want to do. The fact that it doesn't quite do the thing that I would hope for it to do is a different topic. And throughout this talk, I really tried to be funny about the things that don't work, but also make sure you all understand this is amazing technology. This works really well once you figure out how it works. Back there? Is it fast? Actually, it is surprisingly fast. So we had a few things we had to disable for the mobile version, and those were actually on the C++ side. So on the desktop, we do these fancy decompression calculations while you show your dives. And especially if you have a low-end phone, that could slow you down. But the UI itself, whenever we had true UI performance problems, they were typically a developer error, usually mine. Linus still has problems with the folding of dives into trips. And it's funny, with the same phones, on his it's slow, on mine it's fast. So there is still something that we're doing wrong. But overall, the performance is actually really good. In Qt 5.12, there is a QML compiler. I haven't played with it yet. So this is all completely interpreted right now. Well, it's a declarative language anyway. But there is a compiler that's supposed to make this faster. We had a few other issues moving to Qt 5.12. So I haven't quite done that yet. We have a couple of binaries that are built with it, but we're not taking advantage of all of the features. Oh, by the way, my standard rant about packaging for Linux, Ubuntu 16.04 is on Qt 5.5, with 5.12 being the current version. Maybe you can spot the problem. So it's really hard to use modern requirements if you want to. I mean, 16.04 is not that old. It will be supported for more than 2 more years. So you struggle with being able to use the latest version of something if you try to even have some coverage within Linux distributions. There was let's start over here. So the question is, visual design, Qt Creator allows you to use the Qt Designer for desktop applications, but it doesn't have that same capability for QML applications. So maybe it exists and I just haven't found it yet, but I have not found a tool where you can visually design your UI, move things around, and it then gives you the QML that would do it. Qt Designer, which is part of Qt Creator, does the .ui files, but those are only for the Qt widgets, not for QML. There was a question over here, yes? So you were asking about the legacy code, and I'll comment on this in a second, and if we were starting from scratch, if we would do things differently. We don't have legacy code because we have the desktop application. So this is actively used, developed code. We have just recently crossed, so if I look at my server, we see more accesses now from mobile. But so the question is, if I were starting from scratch, greenfield, what would I use? I haven't found anything that truly looks like it would work across all the platforms. Keith keeps telling me I should do HTML5. Oh, you're no longer telling me that, Keith?
I'm pretty sure.
Yes, you told me that. But I haven't found anything that's better. I have shown in the past with migrating from GTK to Qt that I'm willing to break with what we have. If I were to find something that's amazing, I'd look at it. But frankly, I haven't found anything that solves this fundamental problem. You will find very, very few development environments in the first place that have good support for Windows, Mac, and Linux. That's your first challenge. But if you then want to add the mobile platforms and you want to have packaging around that and you want this all integrated in a way that is easier than what we have here, I haven't seen it. Behind there. Yes, so we absolutely have done that. And we actually packaged this for Android, for people with tablets. And we did weird things with magnifying factors so the fields would get big enough. And we have one developer on our developer team who still runs this because he loves it. And he's OK if I tell him that he's weird. He owns it. The user experience is maybe for most people at LCA a stretch. And if you have met divers, a lot of divers are not necessarily technophile. So I don't want to generalize too much, but even this application is still too complex, it's not easy enough for many divers. And so, yes, we tried it and we completely discarded that solution because simply anything that you design for keyboard and mouse or touchpad will not work on a tablet. I encourage you to not waste your time on that because you will give up. It's not going to work. Stephen.
So I'll ask the question. Subsurface 2D is already
Okay, I have to repeat the question. The person said Subsurface is better than anything else that he knows. I think that's what you said, right? Yeah.
It is a very low bar.
It's a Linus is absolutely correct. It is a very low bar. Fundamentally, so dive-log apps are terrible. To all proprietary dive computer vendors, your apps are a disaster. They are so bad. So it is a very low bar. So Shearwater actually has created the Shearwater cloud for the very latest dive computers, for the Taric and the Perdix AI. And I'm actually impressed. This is the first app where the phone version and the web integrated desktop app look similar, work similar. Both are actually fairly usable. They're, of course, only for Shearwater dive computers. So if you have multiple dive computers, you're on your own. But they're certainly getting better. But there are two proprietary apps out there that also support cross-multiple dive computers. So that's MacDive on Mac and DiveLog, whatever, on Windows. They're both single platform. They each have now created spin-off apps by different developers, zero code shared. Integration is, in my humble opinion, not nearly what we do. But they don't have this whole cross-platform squared problem. They're not trying to have a single code base for both desktop and mobile and across all the OSs. And so, no, I don't think there's anybody else who's tried that. You were first, I think. So the question is, the question was what other good candidates I found for cross-development platforms. And I think I was starting this with a somewhat unfair perspective because we had just migrated from GTK to Qt, so I wanted something that would integrate with my Qt backend. And I've looked at Flutter. I've looked at an HTML5 front end around what we've done. But I haven't looked into many of the other proprietary offerings that are out there. So I haven't done a ton of research beyond that because I didn't want to throw away, once again, all my code. And there was another question there. Presumably, the Qt community is working on improving their widgets to look more native on Android and iOS. As I said a few slides ago, there are no widgets. QML, which is what the Qt community gives you, has no widgets. There's nothing. There's rectangles and text fields, a couple of other things. Kirigami has made the strategic decision that they say, we have our own vision of how a mobile app should work. So one of the things, come on, computer, talk to me. One of the things here, you see this action button at the bottom with the 1 or 2 sidecars. This is something that actually Kirigami has pushed this for more than 3 years. And Google last year came out and said, oh, we're moving from the hamburger menu on top to menus on the bottom. So Kirigami has always had the menu in the corner and the action button in the center with this vision that with your thumb it's easier to reach on the phone, right? So they have their own vision of how they think an app should work, and they're not at all trying to become closer to either Android or iOS. They intentionally want to be their own thing. So to answer your actual question, no, I don't think they're working on getting closer. Oddly, the two big vendors seem to also move more of the critical UI elements to the bottom. So clearly the Kirigami guys were ahead of the industry there. But from a will these apps look more native perspective, no, I don't think that's going to happen. So this is a long philosophical conversation. I actually, I have been engaged with the folks who started Qt in the late 90s. I am good friends with some of the core Qt maintainers. I have a lot of contacts into these companies, into Digia, since Nokia disengaged from Qt a while ago. their ideal is to sell into an industrial environment. They are focused on automotive. That is the big moneymaker today. So the Tesla UI is written in Qt, for example. They aren't, as a company, focused on this extreme niche that we are in. As I said, I haven't found another project that's trying to do this. So yes, I occasionally reach out to my friends at Digia, to the folks that do Qt professionally. It is the Plasma community that is the other one that is kind of playing with this overlap. And they are the ones who are most responsive. And I've been super lucky in getting great help from them. Back there in the center. So we have learned the hard way that trying to track Kirigami too closely can lead to very interesting effects in your application. The Kirigami developers, like many other open source projects, they're by far not alone. One of our core libraries does that to us all the time. They're not really good in maintaining 100% stable to their users. Linus is very outspoken on this whole never break your user. And that's the rule number 1 in the Linux kernel, which I think is one of the key rules why the Linux kernel has been so tremendously successful. Very few other projects do this. So we basically update to the latest Kirigami version every 2-3 months, and then usually go through 2 weeks of fixing all the things that are broken, occasionally reverting and going to the community and say, hey, how does this work now? Because there is no documentation what changed, of course. So, and because of that, we basically have in our source code a specific hash of Kirigami that we just check out, copy things over, and build. I don't even know if we are on Kirigami 2. I think we are. I remember that when that shift happened, because they changed some of the ways you can make pages visible and invisible, and that broke things for us, and we needed to fix this. So I'm pretty sure that we are now on a 2-point-something version. But we are typically on a random hash where things just work. And then we stay on that for a while. And then we try a new version and see, is it helpful? Okay, I think we're out of questions. Thank you very much. I hope this was interesting.